So we have to give it up to Paul. He's really brave to bring up a programming talk to a search conference. How many people have seen a programming talk in any of the SEO search conferences? Just one person. It's really brave. So I have a big challenge, which is I have to keep you awake. I hope you guys had really strong coffee. How many had strong coffee? Because this is going to get really intense. And at the same time, I have to get you excited about, as I am, about coding to solve really complex problems that sometimes appear to be impossible. And my approach, I'm a trained engineer, but I don't see programming as an engineer. I see it as a practitioner because I don't really have time to be coding every day. I run a business. But I see it as I see programming as a way for us to be able to communicate with computers, developers, and solve really difficult problems. So what are we going to be covering today? I'm really excited because of all the overlap with the different speakers. Brittany talking about machine learning. So my approach is going to be that we're going to be solving a specific problem that we face, a really painful problem that you guys are going to be familiar. And we're going to be applying more and more sophisticated solutions to see how we can get better solutions as we get into more advanced programming topics. So let's get started. Who's excited about it? Good. Great. So why would you want to program when you can hire a developer, right? And to illustrate this, the way that I look at is programming. I don't see it as an extra skill that you need to have. I think everybody can code. I think about if you can't program, you actually are constrained. And I'm going to illustrate that with a story from my childhood in the Dominican Republic. So when I didn't know until I was in my late 20s that I didn't know that I couldn't see well, that I needed glasses. Very surprising. I would sit in the front row, and that was the way that I needed to see. Fast forward a few years later, when I started visiting the U.S., I would always get lost because by the time I was able to see the signs, it was already too late. I can imagine, like today, the first time I put my glasses on. It was just a magical moment. I would spend the first week just taking the glasses on and off. Wow, I was missing all this. You were there. Wow, it's just looking at just the trees and the details. If you've never used glasses, if you never needed them, it's kind of like the difference between having standard definition and high definition, right? So that's what we're talking. I was constrained from my vision. If you can't code, you're also constrained because you don't really know what you're missing. And one of the cool things that you can do when you have that mindset of programmer is that when you face problems, you're not just thinking about, oh, I can understand this problem, but you can actually see multiple ways that you can solve it, which is really fascinating and gets you excited about actually trying to solve the problem. And the other advantage that I've seen with that is that with the developers, you can bring a new perspective. Developers are fantastic to actually get the code without errors. My code sucks a lot. You make all these errors. But I can bring new ideas. When I spend time with my team, they said they're stuck with something. You try this, you try that, you try this and that. And we can actually make a lot of progress. So now let's jump into the actual challenging problems that we're going to talk about. Let me bring a story back in 2016. One of my clients were going through a massive migration. They were changing from IBM WebSphere, their e-commerce website, to hybrids. We spent a year, and their WebSphere website had a more hierarchical architecture where we had categories, product listing pages, and product detail pages. And in the hybrid side, they made the business decision to flatten the URL architecture. We thought that was a really good idea. We didn't see any problems with that. We said, wow, we came up with this clever solution to automatically map the URLs. And what we did was, we will first map automatically the product URLs by the SKUs because they remain the same between the two platforms. And then for the category pages, which was the more challenging mapping, what we did was we will automatically find the closest matching category by which ones had the biggest overlapping products. Wow, we felt really smart about coming up with that. So we're really, wow, this is going to be a great success. Guess what happened? Boom. Traffic tanked. So terrible, frustrating experience. And anybody working with big companies know that single-digit losses can be, you're talking about millions of dollars, and a lot of heads were chopped out of this migration. We were next in line. So we had to come up with a good idea to reverse this for the client. And what we came up with is a solution I'm going to explain with you guys. We're going to build it up, which is an analysis that we did where we were able to quickly pinpoint what caused the problem. It was related to the category pages, that massive consolidation that we made. And let's see how we actually pull that together. We call that analysis a winners versus losers analysis. And that's what we're going to be building up today. So, yeah, there's going to be code snippets. I'll try to mix it up with some stories from Dominican, but hopefully you're going to stay awake. But I'll be tweeting out my decks. You get access to the links. There's a Jupyter notebook. You're going to be able to access the exercise. So let's get started. One of the reasons why I love the winners versus losers analysis is that you can narrow down the problem a lot quicker than doing a full audit, which is essentially taking the bidding path. And we're going to use some more recent exercise we did with a client, where they moved from a platform called e-commerce v3 to Shopify. And this is what happened. This is going to be the output of our exercise. We had this nice visualization where we can see what happened, what categories, what type of pages were affected by the problem more granularly. Let's see how we build this together. Ready? Coffee in hand and everything? Let's dive in. It's going to get intense now, right? So the first one is, we're taking it step by step. First is do something simple, which is pull the data from analytics automatically. Let's build up a pandas data frame. Who's familiar with pandas here? Who loves it? It's great. Great, fantastic tool. You're going to spend a lot of time with pandas, which is essentially kind of like Excel in steroids. And we're going to perform some set analysis to isolate the pages that lost traffic. So let's dive in. Our toolkit to do this, obviously Python, right? There are some links to cheat sheets that you can use. The Jupyter notebook, as Brittany mentioned, Google Collaboratory is fantastic for this. You don't have to do a lot of setting up on your computer and everything, so get started really quickly. Pandas, indispensable tool for data analysis. Requests to be able to pull the data from the APIs. And how many of you guys are familiar with Google Query Explorer? Okay, a lot of great people here. So this is, I call it Google Analytics behind the curtain, right? So you can actually build queries, pull data. One of the cool things you can do with Query Explorer is that you can create an API URL that you can fetch from Python without doing really complicated setup, which is the alternative path for that. So this is how we pull the data. One of the things you want to take into consideration when you pull the URL from Google Query Explorer is the token, which is what allows the authorization to take place. It expires in about an hour. And one of the cool things you have with requests is that the JSON output of the API, it builds a really powerful data structure for you. One of the limitations if you use the Query Explorer manually, as you guys know, is that you can only get up to 10,000 requests, right? Everybody's seen that. So with this nice little snippet of code in my notebook, we'll be able to actually build a data frame by iterating, paginating through the set and build it out completely. So make it a lot easier and simpler for you. Right? This is how we're going to be building out the data set into a data frame. And then for you, some concepts about how we're actually doing the analysis by isolating the pages that lost traffic, similar to the way that you do this in SQL databases by using joins, right? So in this case, we're using an outer join to do the analysis. So we're analyzing the data by how many pages, the number in new users, and we're looking at where the difference is greater than 0 is the winners, 0 is there was no change, less than 0 is a percentage change. When you're doing this kind of analysis, you can easily make mistakes. So I also like to add some code to double check and make sure that we didn't make any mistakes. So it has to make sure that the totals add up. Okay. And this is the output, right? So we put all this work, now we see the results, right? So this is the exciting part about programming, right? You spend all this time, it's hard to get it right, but at the end, it's beautiful when you actually get the results that you want. Pandas also makes it really easy for you to export this into CSV or Excel files directly from the notebook, right? So now, who's ready? So this is a marathon, as I said, right? Who's ready for part 2? It's gonna get increasingly intense, right? So in part 2, we're gonna get a little bit more useful output, which is we wanna group the pages. Instead of getting the list of pages that lost traffic, we wanna learn what type of pages lost most traffic, right? And for that, we're gonna use regex. That's the manual approach to do this exercise. And in addition to this, because we moved from one platform to another where the URLs are completely different, we're gonna crawl the URLs, the original URLs, and we're gonna do the comparison with the final URL of the redirects, so that we're actually comparing apples to apples. So that was a limitation in the first approach. How do we do that with programming? Our toolkit, regex, here's a URL for you guys to check, learn a little bit more about this. Sorry that I have to go fast over this, so Paul, I think, is gonna be covering this in more detail. And here's some tool for you to make sure that your regex are working correctly. And this is the code for crawling the old pages. Make sure that the status code is within the 301, 302, 307. Sometimes you see the mistake of trying to check from 300 to 399. It's gonna fail because some 300 codes, like 304, is not really a redirect. It has a completely different meaning, like the page didn't change. And because we're crawling the site with this, we don't want the developers to get mad at us because we're taking the site down by the DOS in the website. So it's always important to have some sleep on your request when you're doing this. When you're using third-party tools, they will do that automatically for you. When you're doing it yourself, you have to be more careful to keep your job, right? So this is what the regexes look like. For Shopify, this is the patterns of the URLs, the products, and the categories. I introduced a little bit some advanced concepts in regex, which is negative look-aheads. I have some links here for you to check about that, why we need to use that to make sure that we match them correctly. And this is the beautiful output, right? Fantastic, right? So now we can see that the category pages, the collections, where the biggest loss was for this particular website. You can see the products lost a little bit, not much, and then all the pages besides products also lost very little, right? And this is the output, right? Again, a lot of work, but the results are worth it, right? Love it. Who's loving it? Great. Now, a lot of talk about negativity. We can use the same winners versus losers analysis to also understand when you actually hit a home run for a client. This is a client we took them for over 100% that they were doing year over year last year. Took them to over 300%, which was a big win for them. But we say, wow, how did we do it? We didn't even know. And then with our analysis, we isolated the problem, the solution to actually some infinite crawl spaces that they had on their website. We identified were preventing Google from actually getting to the actual pages that made the difference. So this was a big win for us. So now, manually writing regex for large sites is a lot of work. So now we're going to get into really the interesting stuff. How do we generalize this? With machine learning. Who's excited? We're going to see some machine learning code. But before we do that, let me brag a little bit about my country, right? I have to, right? Well, I get kicked out if I don't make baseball analogies from Dominican Republic, right? Who's a Boston a fan of baseball here? Who follows baseball? Great. So I don't know if you know that Dominican Republic has the most Major League Baseball players than any other foreign country outside of the United States. Who knew that? Right? So then, why are we Dominicans? I'm a terrible baseball player, but I feel like why are we so good at this game? Well, part of the reason that we're really good is because Dominicans, they don't have other choice in terms to become wealthy. You know, it's a developing country, so this is one of the reasons we can do well. But another thing that you don't know is that we play a game, we call it Batista. This game is like baseball, but in hard mode. So you have to hit up with a broomstick a 5-gallon bottle of water. I don't know if you play this game, it's really fun. You develop some really interesting skills that makes you, when you're playing baseball, feels like it's an easy game, you're playing something really hard. And I made this analogy because deep learning, machine learning, I put a lot of time and effort on this, because if you can hit a BTJ, you can hit anything. If I can do really well machine learning and deep learning, I can essentially solve any SEO problem. Okay? But not this one. Not this one. You don't want to waste time, just so many tutorials just about hot dog and not hot dog, right? So another concept here to understand is regex, great for pages that have patterns, like we saw before that. But what if they don't have patterns and they only have numbers? Then that we have to depend on the content of the website to be able to do some classification. We're going to get something really interesting. So this is what we're going to do. Instead of matching the page groups with regex, we're going to match them automatically. You're going to love this solution. So we're going to collect some training data, and then we're going to prepare the training data. As Brittany mentioned, you have to hold out some data to make sure that it's accurate. You're going to find the best model. Our toolkit, again, beautiful soup, will allow you to do the analysis on the content of the website with the XPath, some links for you to follow. We're going to use scikit-learn to do the machine learning part of the exercise. And I want to tell you how we're going to do about doing that. So a company called Bloomreach, where they mention how they do this kind of analysis. So what they do, and this is what I call a bottoms-up approach, when you give problems and data to engineers and scientists, they take a bottom-up, they try to find patterns in the data. They don't have the practitioner higher top-level understanding of what's going on. So in their approach, they're just using class IDs, HTML tags, et cetera, to try to find a model. And they did really well, right, 90%. Right? This is my approach. I am not looking at it as an engineer. I'm looking at, hey, what is the difference in these type of pages? Product pages has big images. Product detail pages has smaller images and more of them. Let's just use that as a training model. And this is my training model. So I built the model using that simple idea, and it's a lot better, right? I deserve an applause, right? Very good, right? So the linear SVM performed 97.5% with that simple idea. Much simpler and very easy to verify. And this is the one trick that we use to do that is it's a lot of bit, the concept works, but trying to get dimensions of images in HTML is not very accurate, so we approximate it by just looking at the size of the image, which is the equivalent of multiplying the width and the length of the images. This is how we created the bins. When we create the images, it's going to be different sizes. We corral them into 50 different categories by doing this exercise, by conversion. And that's the hardest part. The hardest part is just getting the data and organize it in the right way. The best part is that the actual machine learning is just that one line of code. Just display the data set there, right? And then we're doing the finding the best model by performing a great search with some standard parameters there. That's what we did there, right? Who's still awake? Great. And when you're doing machine learning, it's not 100% correct, so you always have to confirm that what you're doing is doing a good job. So this is called error analysis. So a popular and useful tool is the confusion matrix, which essentially, in one side you have the true data, and on the other side you have what you predicted. And here we can see where the model performed really well, which is the dark blue, which is the product, and where it makes the biggest mistakes was in the page type was not the products or the categories, which is the NA that we make the biggest mistakes. So you can see where you need to improve. Either you adding more data or changing the algorithm. But we can do better than this. Who's still with me? Still have strength, right? We're going to get to deep learning, right? So with deep learning, one of the cool things we can do is we can do more granular analysis of what caused the problem. Is it because the pages the products are not available, or the different colors? What caused the problem more granularly on the page? And one of the techniques that we can do, because when you think about deep learning and SEO, you're thinking about only natural language processing. You can actually use computer vision for this, which is really cool, right? Our toolkit, TensorFlow, and Keras. And to explain deep learning, there is this concept that is called the information bottleneck, which is essentially you're taking data in high-dimensional format, and then you have this compression going on in the deep learning. In the compression exercise is what actually allows the computer to learn the classification, object detection, all the different ways that you can do that. One neural network architecture where you can see this in action is the autoencoder. A lot of the things that happen in deep learning is encoding things from high dimension and then decoding them to perform things like taking an image in black and white and adding color. That's some of the cool stuff you can do that. Another cool things you can do is caption generation. Think about images where you want to add caption, where you want to add the alt text. This is something that works. This is something that actually we're seeing this. It's really cool. And there is really powerful tool called TensorFlow Object Detection API. You can use this. This is something that we've done. It's also Google AutoML. Something that we've done really successfully with this is labeling, taking screenshots of images of page types and labeling the elements on the pages automatically with this stuff. It's really cool stuff. And you'll think, oh, yeah, I need a lot of data for this. Something called transfer learning, where we only needed about 4,000 labeled data sets. We're able to do this, right? But if none of what I've talked about gets you excited to check my notebook, I think this one is going to do the trick. Who's seen this article about Neil Patel and Troy Hunt, where Troy Hunt was complaining about Neil Patel advising people not to install SSL certificates. Neil Patel never responded. So I asked myself, what will happen Neil Patel's response if he actually wanted to respond? So I trained a neural network on tweets from Neil Patel and Troy Hunt, and this is what the neural network said that Neil Patel would say, right? So the definitive guide to voice spam and Twitter organizations and how to fix them as SAP, faithful cell advertising. So this is going to be really fun. This is in my notebook. So I hope if you guys don't try anything else, at least this gets you to try it. And you can change the name and and have fun with your Twitter followers. Okay? So in summary, we see that programming can really solve really interesting problems and can actually be really useful, right? So I hope that you guys get excited about this. Spend a little bit of time every day. As I said, work backwards from problems, isolate the tools, and as Jamie said, Stack Overflow is a godsend. So you don't have to figure out everything. You can just copy and paste from Stack Overflow. This is great. Yeah. Okay, about us, we're a SaaS company. We're going to be launching an app in Cloudflare that essentially fills that last part of the implementation part of the SEO, the technical SEO implementation, by doing that with an app in Cloudflare. And feel free to check my website and get an invitation for that. Hope you guys find it useful.
Wonderful. Thank you.